Hey guys, so this is section 10.1, the ellipse, and ellipses are circles that kind of got squished. They're circles with like a non-constant radius, basically. So we have one side that's going to be long, one side that's going to be shorter. And so this is called the major axis. This is the minor axis. These points out here where the axes meet the ellipse are called the vertices, or vertex for singular, vertice for plural. Center, in this case, the center is now going to be HK. So you got to let go of that being the vertex. But the center is where everything else is based, so it kind of makes sense that it ends up being the HK. And then ellipses also have a focus, or foci, I think is how it's said. I'm kind of guessing at that. But they're here and here. And so everything kind of interest runs along this semi-major axis, or major axis. What else do we have on this? We have A, B, and C. So let me talk about that for a second. So A is going to be the distance from the center to the vertex, the major one. B is going to be the center to the minor vertex, the short side. And C is going to be the center to the focus. The formula for that is a squared minus b squared equals c squared. So it's like the Pythagorean theorem, except it's a minus instead of a plus. And it actually is the same triangle, and it's the same thing. It's just A happens to be labeled the long side in this drawing, so the A would fit right there. And so it's really b squared plus c squared equals a squared, so I just wrote it in the order of the Pythagorean theorem with the minus to make it a little easier to remember. So we have two flavors of ellipses, and all of that same stuff is true over here. This one, the major axis runs along x. This one, the major axis runs along y. And in our formulas down here for an ellipse, the way that we can tell them apart is the big number, the A, which is going to be the semi-major axis, this distance, is always under the letter that the axis is running along. So if it's going long ways on x, it's going to be under x. And then here you can see they flip. So if it's going long ways on y, it's going to be, the big number is going to be under y. And that's that major axis again. Other than that, this is all the same. It's just orientated, rotated 90 degrees essentially. And so now A here went side to side, A is up and down over here. And same thing, B is reversed and C is reversed. Other than that, it has all the same features. And our basic form of these is going to be x minus h, and that h again is the center, the x coordinate, and then k is the y coordinate in the center of the circle. And then over A, which is this length, and then B, which is this length, each of those squared, that equals 1. This is basically the, if you've seen the formula for the center, for a circle, it's just like this, but with an r squared over here, and that's if these were equal, we would just clear the r squared on both sides, and then that would be your equation for a circle. So let's see what all that looks like with some examples, and hopefully again that'll make more sense once we actually get into some problems. Okay, question 1. We're going to, I'm going to start by just graphing what it gave me, and that's going to help me orientate where things are. So center's at 0, 0, so again starting with the concentric at the origin. We have a vertex at 3, 0 right here, and a focus, so that's a vertex. And anytime they talk about vertex, they're talking about the major one. They would have to tell you it's the minor one if that's what they're referring to. Focus is right here at -1. And so with that, I can fill in a bunch of other information. So if this is the center and that's the vertex, that means I have to have another one on this side, on the opposite side, because it's going to be symmetrical. Likewise, I'll have a focus right there. And then to get the, what that is so now I have a couple of the distances. I have center to the vertex, and I have center to a focus. So that means I know A is 3, that was our center to vertex. And I know C equals 1, because that's our center to a focus. I'm just counting that right off the graph. If you read this in the book, it'll probably show a more algebraic way to get there, where they just sort of have these points and have you subtract things. To me, it's easier to just grab it off the picture, so I'm kind of a big fan of doing these graphically. But the book would have a different take on it if you want to see something a little bit more algebraic. And there's a little bit of algebra coming up, so I know A and C, and remember we have that relationship a squared minus b squared equals c squared. So I know these two, so I'm going to get B. So what I'm going to do is I'm going to swap these, so then a squared minusing this over c squared will equal, add this over b squared. And so a squared we know is 3 squared minus 1 squared for c equals b squared. So that'll be 9 minus 1, or 8, equals b squared. Or rooting both sides, b equals root 8. So that means b is about, if you throw that in a calculator, you don't ever want to use the decimal in answering the question, but it's helpful for sketching the graph. So b is going to be about 2.8 is what root 8 is. And so coming over here, we'll go 2.8 up and then 2.8 down. And so this one's going to be fairly close to circular because the major and minor axes are pretty similar in length, 3 and 2.8. But it still is the short squatty kind, just not that squatty. So then to get our equation, so it's the short squatty kind, so what we're plugging into is x minus h squared a squared plus y minus k squared b squared equals 1. And in this case, h and k, the center right here, are already zeros, so these are just going to reduce down to x squared up top over a squared. So a was 3, so a squared would be 9, and then plus y squared, because that's 0 again, over b squared, which I have right there, is 8, and that would equal 1. So that'd be my equation to the ellipse. Okay, so number 2 is fairly similar. This time it's not going to be centered at the origin. So this is going to be our HK. So 2, 2 would be right there. We have a focus at 4, 2 and a vertex at 5, 2. And so then if I have that, that means I'm going to have matching points on the other side. So the focus was 2 over and the vertex was 3 over. And so what that gives me is A is 3, because that's my center to vertex, and C is 2, so that is center to focus. And so this goes 3 squared, I'll do it this way this time, plus b squared equals 2 squared. And so that'll be 9, oops, I'm sorry, that's a minus. 9 minus b squared equals 4. And then I'll bring the 4 over and the b over this time. So 9 minus 4 equals b squared, and 5 equals b squared. And then with that, b would equal root 5. And root 5 is about 2.2. And so again, don't put that in the computer, but it's good for graphing. So then 2.2 up and 2.2 down from the center. And then that defines our ellipse. So another short squatty one. So this is going to go in that same formula as last time. So let me write it out one more time here. X minus h squared plus y minus k squared. This is a squared, b squared equals 1. And so then from there, we're going to go x minus 2, because that's our h, and then squared plus y minus the other 2 squared. This one's going to be a squared, so a was 3, so squared makes 9. And then this is going to be b squared, and b squared was 5. And that equals 1. I think there's a couple of questions on the homework where they have you enter these as 3 squared and root 5 squared. And I have those noted in the directions, so make sure to check out the directions on this one, because I think there's a couple of kind of funky versions of answer entry to look at. And I think that was it once we got the equation. Yeah. Okay, similar question. So let's see. This one we have a focus at 4, 2. So x is 4 and y is 2. A vertex at 4, negative 7. So that's way down there. So there's a focus and -7 would be here, vertex, and a center at 4, -2. So x is 4, y is -2. So there's the center. And so it's kind of that same thing again, but this time everything's lining up along y, so that tells us we're going to have kind of the tall, skinny version. So for A, we're going to go 1, 2, 3, 4, 5 boxes. A is 5, and then C is 1, 2, 3, 4. So then we can go 5 squared minus B squared equals 4 squared. I'll flip-flop these. 25 minus, that'd be 16, equals B squared. 9 equals B squared, and then B equals 3. So with that, I can draw the rest of this ellipse. And so let's see, A was 5, so this would be here. The other focus would be right there. You'll see on the next round of questions, the same as the parabolas, it goes, here's the stuff, find the equation, and here's the equation, find the stuff. So even though it's not asked for, I like to just draw it in each time. And then the semi-minor axis would be here and here. On the computer, if it only asks for 2 vertices, it's talking about the major ones. If it asks for 4, it's asking for the minor ones also. And then just kind of connect that with a sort of a little Easter egg shaped thing here. And then that's our ellipse. So then to get our equation, this one is the other formula. This is going to be y minus k squared. Oh, I'm sorry, I'm doing a hyperbola for a second. This is going to be x minus h squared plus y minus k squared equals 1. But this time, instead of a and b, it's going to be b's under x because it's the short one, so it goes along x. And then a is always the major axis, so this time it's along y. So that's how you can tell the difference. And so this will be x minus 4. And then b squared was 9. Again, some of them might ask for 3 squared there, so just be careful on how they want the answer. And then y minus a -2, so we'll just go plus 2 over a squared, so that'd be 25 equals 1. The other thing I forgot to say at the top, and I don't think I said in the parabola video, if you're in my class, these little intro diagrams with definitions, that is with the exam. So that's part of the exam notes for my class. If you have someone else, not necessarily the case. So this next one, now we're given the equation, and we're asked to find center, vertice, foci, and graph the ellipse. So first thing we'll do is, I think I'm going to grab the center because it's just kind of sitting there. So the center is going to be x is 5 and y is -2. The rest of it is going to be the vertice and the foci. They're going to be much easier from the graph, so I'll do that there. I know it's going to be a tall, skinny graph because the 9 is under the y. So A is going to be 3 and B is going to be the 2. And so to find C, I'm going to need that so that I can find the location of the foci. We're going to go a squared, so 3 squared minus b squared, 2 squared equals c squared. So that'll be 9 minus 4, so 5 equals c squared, or c equals root 5, or approximately, for graphing purposes, 2.2. And I think with that we can get the picture, and then from the picture we can get the rest of this. So come over here. Our center is at x is 5, y is -2, so that'd be right there. Remember, it's going tall, skinny, so A is going to run along the y-axis. So there's one vertex, and here's the second vertex. And so right there, I grab those. Vertice. So this looks to be 5, 1 is the first one. And then 5, let's see, 2, 4, 5. 5, -5. And then the minor axis is 2, so we'll put this here, and then that defines the ellipse. And so if it asked for it, these were the other 2 points that you would list as vertices if it wanted 4 of them. And then the foci, so that's going to be 2.2, so that's going to be just about there, right about there. So then how do we say that as an ordered pair? So what we're trying to do is describe the location of this point. So we know it's at x equals 5, so that part's cool. And kind of once you figure out, you know, the 5, you see how the 5 is repeating everywhere, all this stuff is going to be along 5. So there's our first coordinate. And then what we're going to do is we're going to use the y-coordinate of the center, which is -2. And then if I go up root 5, right, because that's that distance, I would be at this point. So that would be plus root 5. And if I went down root 5, I would be at this point. So that's minus root 5. So we just use the center and then plus or minus that distance. And that's how we rewrite this. Don't use the decimal. Computer will mark you wrong. Definitely use the exact form of the answer. So center, focus, vertice, and graph. So I think that was it for that one. Okay, and then in this example, it gets a little bit trickier because we have to do the completing the square thing. But this time we have to do it twice, and with parabolas there's only one square, and this time both x and y have square terms. So let me show you how I write this out. So x squared plus 4x, and I'm going to leave myself a little bit of room there, and then plus 16. And then if you look at these formulas, there's never like something in front of the x or y, it's just plain x and y. So I'm going to factor that 16 out front, and then it'll be y squared minus 2y. I'll leave myself some room again, equals, and then this 4 isn't helping. Well, it could have helped there, but we don't always know that. So I'm going to move it to the other side. And then I'm going to complete the square in x and in y. So for x, so we got this one then. So in x, we got half of 4 made 2, and then 2 squared makes 4. So we're going to go plus 4 plus 4. The y is a little bit trickier. So half of 2, that part's not tricky. Half of 2 is 1, and then 1 squared makes 1. So we're going to go plus 1 here, but it's not a real 1. It's really a 16, because if I distribute this back, you can see I'd have 16y squared, the 32, but I really just added 16, so I have to be careful to add 16 to that side. And so now, for the x's right here, this is going to factor to x plus 2 squared. And then that 16 is still there. And then this piece will factor to y minus 1 squared. 4's drop out and it equals 16. So we're getting close. But this over here, remember in the formulas, is always a 1. And so that tells us what we have to divide through by. So to make this 1, I have to divide by 16. So I divide here by 16 and here by 16. And so now I have x plus 2 squared over 16. These cancel, so that'd be y minus 1 squared over 1 if we need to put something there, but that helps us spot what our b is going to be, and that equals 1. So with that, now I know that a squared is 16, so a is 4, and b squared is 1, so b is 1. And then I can do a squared minus b squared, so 16 minus 1, that's a squared minus b squared equals c squared. So 15 equals c squared, and then root 15 equals c. And for graphing purposes, that's just a little bit less than 4, because root 16 would be 4. So then we'll kind of get some of the stuff drawn in. We know the center now, and that's going to be -2 and +1. So -2, +1. Oops, that's not the right axis, sorry. -2, +1 right there. And then we know A is 4, so it'll be 4 this way and 4 this way. And we know B is 1, so up 1 and down 1. And I'm going long ways because big numbers are under X. And then we just draw kind of this squatty little ellipse here. And then the foci would be just right like there and right like there, because that distance was almost 4. So just close up against the vertice. So looking at the vertex now, grab those. So this one is at 2, 1. You can see everything's lining up along 1 this time. And so this one's going to be 4, 5, 6, negative 6, 1. And then foci. So this time we're going to run from X to left and right. And it's the 1 that's the constant number. So if you see all these 1s, that kind of helps you get the plus or minus on the right things. It has to be on the X. So we're starting from negative 2. And then we're either going right root 15 or left root 15. So that's our plus or minus root 15 and then 1. Okay, last one. This one isn't in the right form either, so I'll rewrite it. So I'm going to put it in order first. So 4x squared, I'm going to put the 8 over here, y squared plus 4y. And even though this could help out with the y, I'm going to go ahead and write it over here. Just because that would be a hard thing to see, so I'll do this as completing the square. And now that I have everything in the right order, I'll factor 4 out front on this x squared, and I'll leave myself a little space, and then y squared plus 4y, I'll leave myself a little space, equals negative 4. And then completing the square, so for x, same as last one, half of 2 is 1, 1 squared will make a 1. But it's not a real 1, it's really a 4 because it's 4 times that 1. So we have a plus 4 right there. And then for here, half of 4 is 2, 2 squared makes 4. So plus 4 again. So a couple of those will cancel out. And then factoring, I'm going to get 4x minus 1 squared plus, this would be y plus 2 squared equals 4. And since this is a 4, I need to make this a 1, so I'm going to divide everything by 4. So that's going to get me x minus 1 squared over 4. Oops, not over 4, sorry, over 1, because those are basically canceling. And so this one will be y plus 2 squared over 4 equals 1. And so I have my center, and we're going to find vertice and foci. So the center's right here at 1, negative 2. And then I know A, it's going to be a tall, skinny one, because A squared is 4, so that makes A 2. We know B is 1. And then 4, 2 squared minus 1 squared, 1 makes C squared. So 3 equals C squared, and root 3 equals C. And that's about 1.7. And then let's get some of this graphed, and that'll give us these other two. So x is 1 and y is negative 2. We know a is 2, so up 2 and down 2 because it's tall, skinny, because big numbers under y. And then left and right 1 each. So we get that little ellipse right there. And the foci would be about here and about here for when we go to try to figure out the points. So from the graph, the first vertex is at 1, 0, and then the second one is at 1, negative 4. So you kind of see the repeating ones. So we're going to have 1, and then starting from y equals negative 2, we're going to go up root 3 or down root 3. So plus or minus root 3.